Hi. So then today we're doing 2.4. 2.4 is dealing with complex numbers. So to know what a complex number is, we have to talk about what an imaginary number is. So you would have learned about this letter I before in math. Whenever we have the square root of a negative real number, okay, for an example, that would be the square root of -2 or a square root of -5, anything that's a real number. Real numbers are decimals. They are negative numbers. They're rational numbers. They're integers. They're everything, okay, anything besides imaginary, basically. So when that happens, when we have that negative inside of a square root, imaginary numbers come into play. So if you're ever faced with the square root of a negative number, what happens is we bring that negative out and make it an I. So what's left inside becomes positive, and then you can keep moving on with your problem. One important thing to note is that I itself is equaling a negative or a square root of -1. So it's kind of that placeholder for that square root of -1, but we always call it an I because this is not a proper number. So what that means, though, is at any point in time, if we run across an I squared, what I squared would then be is -1. Okay, because if I is square root of -1, this would mean that we're squaring a square root and it's canceling and leaving us with just that -1. So this is a real number, correct? This is not, but -1 is. So if we ever have an I squared, we do have to replace that I squared with that number -1. So this is where the imaginary part comes from. So what happens then is when we write a complex number, it would be in the form of a plus bi. And again, this is just like kind of an equation that we write out of our formula, where we basically have a real portion added or subtracted to an imaginary portion. Okay, so real being the A and then bi being the imaginary. An example of this would be 2 plus 3i. Okay, 2 is a real number, and then 3i would be the imaginary portion. So it's important to know where the imaginary portion of a complex number comes from, but then we also need to know how do we do operations with complex numbers. So that is basically what the greater portion of today is going to be talking about. So we're going to kind of start in the beginning and keep going on. And the first is going to be adding complex numbers. We're going to use the example 3 minus I plus 2 plus 3i. So they're always, our complex number is always going to come in a form of a binomial and a binomial. If it's not or if it doesn't come with a two-part or two-term binomial, then it's not a complex number because that means it's either missing the imaginary portion or the real portion of it, whereas it would just be the imaginary or just the real. So one thing I always like to say when we're doing any operations with complex numbers is you can take that I and treat it like any other variable you've ever seen. You truly get to add it, subtract it, multiply it, divide it like any other variable you ever have. So when we're adding, we're truly just going to take the like terms. Real numbers are like terms. So we're going to take 3 and add it to 2 to get 5. So then after that, we have like terms that have a variable in it or that imaginary number complex I. So when we're adding these two together, we have a negative I and then positive 3i. So this would just add, I have the wrong marker. This would just add to positive 2i. Okay, again, you're just adding those like you would anything else, any other kind of variable that you ever come across. The next is gonna be subtraction. So every time, like every next operation we're going to be doing is just going to step it up just a little bit. So when we're thinking about subtraction, this example is 1 plus 2i minus 4 plus 2i. So there's one thing to remember about this, and then it's just as easy as it's ever been. And you should know this about subtraction, but it's just one thing that's worth reiterating. Whenever we have the subtraction in front of a whole set of parentheses, this subtraction applies to not only the 4, but also the 2i. So what I like to do is truly distribute out that negative or subtraction sign. So this front part stays the same, right? It's just going to stay like it already was. But now a negative times a positive 4, it's going to be a negative 4. A negative times a positive 2i is going to be a negative 2i. Once I've distributed that negative, now I'm good. I don't have to keep doing anything else. It's just important that I apply this subtraction to both of these. So by distributing it, that's kind of an easy way to make sure I do that. Now I can combine my like terms. So this is going to be 1 plus negative 4, which is negative 3. And then after that, 2i plus negative 2i. This works just like anything else. If you have a fully positive version of one thing, that you also have a fully negative version of the other, right? Those are going to add up to be 0. So my final answer would just be negative 3 for that subtraction. Okay. And some people like to say like plus 0i. Well, 0 times anything is just 0, so you don't have to put that 0 placeholder in. Okay, stepping it up a little bit. Now we're going to do some multiplication. So we're going to multiply the following two binomials. 2 minus I times 4 plus 3i. So again, I can't reiterate this enough. It's truly just doing addition, subtraction, multiplication like you've always done it before. So when we have two binomials, what we have to do is FOIL them or distribute them out, right? So this 2 times 4, 2 times 3i. Negative I times 4 and negative I times 3i. 2 times 4 is 8 plus 2 times 3i is 6i, right? If that was an x there, I would multiply the coefficients together and then add that x on. So again, I multiply my coefficients together and add an I on this time. Negative I times 4, negative 4i. Negative I times 3i, negative 3i squared, right? Two x's multiplied together give us a squared. So same with i's. So I'm going to start combining my like terms. I have nothing else for 8, so that just comes down. 6i and negative 4i leaves me with positive 2i. So now there's one thing I said about that I squared. Whenever I have an I have to leave it. But if I have an I squared, I know that that equals negative 1. So I have to replace this I squared or substitute in that value of negative 1. Okay, so I'm going to keep simplifying this out. 8 plus 2i, negative 3 times negative 1 is a positive 3. So now I have one last step of combining like terms to give me 11 plus 2i as my final answer. Okay. So the very last thing we have to talk about then would be division. So with division, this is the one process that's going to be a little bit different than anything else we've kind of done before. You may have seen this process before, but you might not recognize it or remember exactly how to do it. So let's say, for example, that I want to divide 2 plus 3i by 4 minus 2i. So when we're dividing, we're going to see this in this fraction-like division, right? I don't exactly know how to go about dividing these, but one thing that I know that I see wrong is I have an I in my denominator. So why is this wrong? Well, one, it's a negative square root, and we can leave that if it's I, but I know that I does mean that I have a square root. I can never have roots in my denominator. So I'm going to do this division process in which I am simplifying this to get any roots out of my denominator, meaning I'm going to get any i's out of my denominator. So this is going to be called multiplying by a conjugate. What a conjugate is basically the exact opposite sign but same terms. So I'm going to be multiplying this by a value of 1. I take my denominator without the sign over my denominator, again without the sign, because the sign's the one thing that changes. If I have a subtraction sign in my denominator, I'm going to change this to an addition sign. So on the contrary, if this was an addition, I would change it to subtraction. So some people ask, why is this a legal thing? Like, why can I do this? When you're looking at 4 plus 2i over 4 plus 2i, that simplifies down to a value of just 1. Okay? So all I'm simply doing here is multiplying by a funny looking 1, is sometimes what I like to call it. When students get confused, I'm like, what's that funny looking 1? What do we need to multiply by? I'm not changing the value because this equals 1. And this is an expression, so I can't change the value because there's no equal sign. But I'm not changing it because this truly is just multiplying by 1. It just is a much different version of it. So when I multiply fractions, I multiply straight across. So we just learned how to multiply, add, and divide. Multiply, add, and subtract. So all of those skills will become useful when we're trying to multiply and combine like terms. Again, I have to distribute or FOIL these out. So I'm going to start by just my top. I'm going to take 2 times 4, which gives me 8. 2 times 2i, 4i. 2 is out. Now I have 3i times 4. That's positive 12i. 3i times 2i. That is 6i squared. Okay, now moving on to my denominator. Again, if you don't have 4 terms, when you started with 4 terms, then something went wrong. So 4 times 4, 16. 4 times 2i, positive 8i. Negative 2i times 4, negative 8i. Negative 2i times positive 2i is negative 4i squared. So from here on, it's truly just combining like terms. I'm going to bring this back over here. So the first thing I'm seeing is I have no other 8s, so I'm going to put that 8 down, or I have no other constants, I should say. So I'm going to put that 8 down. I have a 4i and a 12i. Let's combine those to get 16i. I also see an I squared, so I don't leave that, right? I replace that with a negative 1. And we'll deal with the rest of that in a second, right? We'll keep simplifying that. Now I have no other constant, so it's 16. And now here's why we are doing this process. I said I needed to get rid of any i's in my denominator. If you multiply the conjugate correctly, you should get a positive and negative version of that same I number, that same imaginary number. I have a positive 8i and a negative 8i. Those cancel, leaving me with just that negative 4i squared. And again, we replace an I squared with negative 1. So I can keep going from there. At this point, you should have no i's in your denominator. I don't, so I'm just going to keep going from here. 6 times negative 1 is negative 6. Still plus 16i. 16 plus negative 4 times positive 1 is positive 4. So now we can combine our last like terms, these constants. 8 plus negative 6 is positive 2 plus 16i, all over 16 plus 4, which is 20. Okay, so this is going to be almost my final answer. One thing that I'm really going to push you guys to do this year is simplify fractions as much as you possibly can. So one way that we do that, especially when we have an addition or subtraction sign in our numerator, is we can split these two fractions up. So I can't simplify this all together. I can't like just start saying like, oh, well, 2 over 20 simplifies down and 16 over 20 simplifies down, so I'm going to simplify this all at once together. It doesn't work that way because of this addition sign in the numerator. So instead what I have to do is say this is one fraction and this is a whole different fraction. So I take that first part of my numerator over my denominator, and then whatever sign came in between those, in this case it was addition, goes in the middle. Now I take the second part of my numerator over the denominator again. I'm doing this process because I think that I can keep simplifying down. I do this process no matter what. I split them up to see if I can simplify. If not, I can leave them separate or put them back together. But what will happen here is I first start with this first fraction, 2 over 20. I know this fraction can simplify down with the fact that 2 goes into 20 10 times. So this simplifies to 1 over 10. Okay, so now secondly, I'm looking at 16 over 20. I can't cancel out any i's because I don't have any in my denominator. What I can do is look at this 16 and 20 though. I know that those both have factors of 4. So this can simplify down to 4 fifths. And of course, we can't forget the I to go along with it. You can put the I in the numerator. You can put it all in the back. It really doesn't matter as long as it's there. So this would truly be my final answer. This process of breaking up the fraction is just one extra step that I'm really going to push to add on this year for you guys, just to make sure that we're understanding just how far we can go with some of these answers. All right, so that is it for 2.4. Let me know if you have any questions.